2025 A-Level Combined Mathematics Paper 1 Part B, question number 11, Part A. We will be discussing Part B in the next video. Part A and B have to do with the roots of quadratic equations. Part A says, let fx be equal to x squared minus 2kx minus k squared minus 1 for x element of the real numbers where k is some element of the real numbers. Given this, we are asked to show that the equation fx equals 0 has two non-zero roots that are real and distinct. So the keywords here are non-zero, real and distinct. It then asks us to say, let alpha and beta be the roots of fx equals 0, and provided that, let r be equal to 1 over 2 alpha and s be equal to 1 over 2 beta, and given that, show that the quadratic equation with r and s as its roots is 4 times k squared plus 1 x squared plus 4kx minus 1 equals 0. And that, if we take the modulus of r minus s as in the distance between the two roots, we get the square root of 2k squared plus 1 divided by k squared plus 1. Given this, we are asked to deduce that the horizontal distance between the 2 points of intersection of the graphs of y equals this and y equals this is square root of 3 divided by 2. So to begin, let's try to show that the equation fx equals 0 has two non-zero roots that are real and distinct. So to do this, let's start with question number 11, part A, which you will be writing in some other paper. Of course, you will have to write your index number somewhere over here and then start the question. Now, since this is in some other paper, I'm going to rewrite the definition of f of x, because I do not really want to switch back and forth in between my exam paper and my answer sheet. So fx is equal to x squared minus 2kx, x squared minus 2kx minus k squared minus 1 for x element of the real numbers and k for some k element of the real numbers. So we are asked to show that the equation has two non-zero roots that are real and distinct. For the real and distinct part, what we need to do is to find the discriminant, because if we can find the discriminant, if that discriminant is positive, then that means that we have a square root of a positive number when you are doing the quadratic formula, which means that both of the roots will be real. And then if that discriminant is not equal to 0, it means the two roots are distinct from each other. So let's go. If we start with that, the discriminant of f of x, it's going to be equal to b squared minus 4ac, which in this case, b, the coefficient of x, is minus 2k. So that means we have minus 2k squared and then minus 4ac. So we have minus 4 times a, which in this case, the coefficient of x squared is 1. So minus 4 times 1 times c, which is this whole thing. So I'm going to write the whole thing as minus k squared minus 1. Now if we simplify this, we can see that this minus 2k whole thing squared is going to give us 4k squared. This minus 4 times 1, we can actually eliminate the 1. Minus 4 times minus k squared is going to give us plus another 4k squared. And then minus 4 times minus 1 is going to give us plus 4. Simplifying down, we get plus 8k squared plus 4. So clearly, this value here, 8k squared plus 4 is going to be greater than 0, and the reason for that is that 4 is a positive number, and k squared, since k is an element of the real numbers, is also going to be a positive number. When you add two positive numbers together, you're going to get another positive number. So therefore, this is greater than 0, and we can say since k is an element of the real numbers, we don't really need to elaborate anything more than that. If we just say k element of the real numbers, they'll get the point that since k is a real number, k squared is positive, so we have a positive number times and plus another positive number, which is itself a positive number. So now that we have that, let's move on to the next bit. From this, we can see that the two roots of f of x are going to be real and distinct. So that's all we can say for now. So we're going to say down here, therefore, the two roots of f of x are real and distinct. And I'm going to label this point where we find that the two roots are real and distinct, equation number 1 or theorem number 1. So now we've proven that half of the thing. We've proven that the two roots are real and distinct. We still need to prove that the two roots are non-zero, as in 0 is not going to be one of the roots. Now, the easiest way to prove that 0 is not going to be one of the roots is to just see what happens when x is equal to 0, because if that thing, f of 0, is equal to 0, it means that 0 is a root. And if it's not equal to 0, that means 0 is not a root. So what we're going to do down here, in order to see that the two roots are non-zero, is to try f of 0. So you can do things like this. It's alright, it's perfectly fine to do things like this. What we're going to do is to try f of 0 and see what it is equal to. So if we do f of 0 will be equal to, if we substitute 0 into here, x squared is going to be 0 squared, so we have plus 0 squared, minus 2kx is going to be minus 2k times 0, and then minus k squared minus 1 is going to remain minus k squared minus 1. So now if you simplify this down, the 0 squared is going to be 0, this part is going to be 0, so we have equals 0 plus 0 minus k squared minus 1, which is equal to minus, I'm going to write it as minus k squared plus 1. So minus k squared plus 1 is clearly some value less than 0, and the reason for that is that k squared is going to be a positive number, plus 1 is still going to be a positive number, so it's non-zero, minus times that is going to be some negative number that is not 0. So we can see this thing is some negative number, which means it is less than 0, which means it's not equal to 0. So we can say once again here, the logic for it not being equal to 0 and being less than 0 is that k is an element of the real numbers. You don't need to elaborate more than this. This is sufficient. So now that we have this, we can see if f of x is substituted with f of 0, as in we try to see if 0 is a root, we can see that 0 is not a root since f of 0 is not equal to 0. So therefore, since f of 0 not equals 0, the roots of f of x are non-zero, which we are going to call number 2. So this is the formula number 2, the other one is formula number 1 or theorem number 1. Now if we combine the two, we can get the condition that they want. They want to show that the equation f of x equals 0 has two non-zero real distinct roots. So to do that, we just need to combine statements 1 and 2. So if we combine 1 and 2, we get that f of x equals 0 has two non-zero, they started with non-zero real distinct roots. Now if you want, you can highlight the keywords here. The keywords are non-zero, real and distinct. So this is what we want. And that is going to be the answer for that part of the question. Now you can write all of this down in like 2 to 3 minutes and finish that part of the question easy, no problem. So you just have to check what the discriminant is, see that discriminant is positive, therefore the two roots must be real and distinct. And then for this bit you can do a little bit of cleverness and try f of 0, and since f of 0 is not equal to 0, you can say that the two roots are non-zero. So now that we're done with that part, let's move on to the next part. So next part of the question says, let alpha and beta be the roots of f of x equals 0, and given that, let r be equal to 1 over 2 alpha, s be equal to 1 over 2 beta, and given all of that, show that the quadratic equation with r and s as its roots is given by all of this. Now to do this, the first thing we're going to have to do is to establish a connection between alpha and beta and the coefficients of f of x equals 0. We can do that easily from the fact that we know that if alpha and beta are the roots of the function f of x equals 0, so we can say are the roots of f of x equals 0, then we can find a connection between alpha plus beta and alpha times beta and the coefficient of f of x equals 0. We can do that because if you have this form, then alpha plus beta, the sum of the two roots, is going to be negative b over a, where b is the coefficient of x, in this case negative 2k, and a is the coefficient of x squared, which is in this case 1. So therefore, for this particular equation, alpha plus beta is going to be negative 2k divided by 1. So going down here, alpha plus beta is going to be negative 2k divided by 1, which is going to be equal to 2k. Now similarly, if we do alpha beta is going to be equal to c divided by a, or the constant term divided by the coefficient of x squared, which in this case is negative k squared minus 1 divided by 1. So we can go down here and write that alpha times beta is going to be equal to negative k squared minus 1 divided by 1, which I'm going to write as negative k squared plus 1. So now that we have this, we can then move on to the second quadratic equation with the roots of r and s. So before that, we need to write in our answer sheet the definitions of r and s. So we're going to write that, and then we're going to write down the quadratic equation with r and s as its roots. So going down here, we're going to say let r be equal to 1 over 2 alpha and s be equal to 1 over 2 beta. So now given this, the quadratic equation with roots of r and s is going to be given by the following formula. It's going to be x minus r times x minus s equals 0. Because if you consider this quadratic equation, when x is equal to r is going to be equal to 0, and when s is equal to x is equal to s, it's also going to be equal to 0. So therefore, this is the quadratic equation corresponding to the equation with the two roots of r and s. Now if we simplify this, we can see that this simplifies down to x squared plus minus r, or we could write like this. We could write minus r plus s times x, because if you multiply this minus r times x, you get minus rx, and if you multiply this x by minus s, you get minus sx. So combining those together, we get minus r plus s times x, and then if you take the constant term, that's going to be minus r times minus s, which is going to be plus rs equals 0. So now we're going to substitute into this the value of r and the value of s. Value of r is 1 over 2 alpha and value of s is 1 over 2 beta. Therefore, the quadratic equation becomes x squared minus 1 over 2 alpha plus 1 over 2 beta times x plus 1 over 2 alpha times 1 over 2 beta equals 0. Now if we clean things up here, we're going to get x squared over here, x squared, and then minus, and for this bit what I'm going to do is to take a common denominator of 2 alpha beta. So we're going to divide by 2 alpha beta, and then on top what we're going to get is an alpha on top from here. So we cross multiply, this is going to have an alpha, and this part is going to have a beta. So we're going to get alpha plus beta times x. And for the next part, 1 over 2 alpha times 1 over 2 beta is simply 1 over 4 alpha beta. And that's going to be equal to 0. Now, you can see that this formula here contains alpha plus beta and it contains alpha beta. And we know that we have already found alpha plus beta and alpha beta, and we can directly substitute them into here, which is exactly what we're going to do. So we can maybe call this maybe equation number 3, equation number 4, and we can go down here and we can say from 3 and 4, so we could do 3, 4, give us that this is going to be equal to the above quadratic, is, and then we can just substitute alpha plus 1 and alpha plus beta and alpha beta. So that's going to give us x squared minus alpha plus beta is going to be 2k, so divide by 2 times alpha beta, which is 2 times minus 1, so minus k squared plus 1. So that's this, and then that has to be multiplied by x, and then to that we need to add 1 over 4 times alpha beta, and alpha beta is equal to negative k squared plus 1. So we get minus 4 times k squared plus 1, and that whole needs to be equal to 0. Now this is not the form that they have in the answer sheet. In the answers, in the answers that they have given, it as 4 times k squared plus 1 x squared minus, plus 4k x minus 1 equals 0. In order to get this, what we need to do is to multiply both sides by 4 times k squared plus 1, because if we do that, we can see the x squared coefficient becomes 4 times k squared plus 1. If we do that, we get 4 times k squared plus 1 x squared, and then as for this bit here, we're going to get this 2 and 2 cancelled. We have this part left over. We have a minus and a minus, which is going to turn into a plus. We have k divide by k squared plus 1, and we're going to multiply by 4 k squared plus 1. So since k squared plus 1 is not equal to 0, we can cancel this k squared for the k squared that's going to be coming, and we're going to get finally a 4 left over times a k. So that's going to be 4k x. And as for the last bit, this is 1 over minus 4 times k squared plus 1 times 4 times k squared plus 1, which is going to cancel out the 4 times k squared plus 1, but it's going to leave the minus. So it's going to be minus 1, and that's going to be equal to 0, which is exactly what we had up here. So therefore, we've shown that the quadratic equation with the roots r and s is equal to 4 times k squared plus 1 x squared plus 4kx minus 1 equals 0. Now the next part of that same question is asking us to find that the modulus of r minus s, or the distance between these two roots r and s, is equal to this thing here. So in order to do that, what we're going to do is to consider the two roots. Now in this case, the two roots r and s are the two roots of the above equation that we have here. So therefore, from above, the two roots r comma s are going to be given by, if we apply the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, which is going to be negative 4k, so minus 4k, plus or minus the square root of b squared minus 4ac, which is going to be 4k squared, which is 16k squared, minus 4 times a, which is 4k squared plus 1, times c, which is going to be equal to minus 1, so negative 1, and all divided by 2a, which is going to be 2 times 4 times k squared plus 1. Now if we take a look here, we can see we can simplify certain things. If we take r comma s here, we have a 4k here, we have a 4 in the denominator, and if we look inside of our square root, we can see we have a factor of 16 here, and inside here we have a 4 times a 4, which means we have another factor of 16. So if we take this divide by 4, we take it into the square root and we divide this part here, we are going to get a minus k plus or minus the square root of k squared, and then if we simplify everything else, this minus and minus are going to cancel and just going to give us a plus. This 4 and this 4 are going to go, which is just going to leave us with k squared plus 1. So we're going to have plus k squared plus 1, and that's going to be divided by this 4 is gone, so we have 2 times k squared plus 1, which is going to be 2k squared plus 2. So now we have this. Now if we simplify this down a little bit further, we can see we have r comma s is equal to minus 2k, so minus k plus or minus the square root of 2k squared plus 1 divided by 2k squared plus 2 plus 1. So now we have this. Now if we consider the modulus of r minus s, one of the values of this, which is going to be the, let's say the plus value is r and the minus value is s. In which case, the modulus of r minus s is going to be the modulus of the plus value, which is going to be minus k plus the square root of 2k squared plus 1 divided by 2k squared plus 1, and then minus k minus the square root of 2k squared plus 1 divided by 2 times k squared plus 1. So we have this. This is going to be the modulus of r minus s. Now if we simplify this, we can see that this minus k and this minus k are going to cancel out, so we can basically ignore that part. As the other part, the plus square root of 2k squared plus 1 and this minus square root of 2k squared plus 1 are going to turn into 2 times square root of 2k squared plus 1. So therefore, the modulus of r minus s is going to turn into the modulus of 2 times the square root of 2k squared plus 1 divided by the denominator of 2 times k squared plus 1. Now if we cancel out this part, we can see we have the modulus of 2k squared of the square root of 2k squared plus 1, which is going to be a positive value, divided by k squared plus 1, which is also going to be a positive value. So if both of these are positive, then the overall value is positive, and therefore taking the modulus does nothing. So we can finally say that r minus s modulus is equal to the square root of 2k squared plus 1 divided by k squared plus 1. Now we need to make an argument on why we remove the modulus. We need to say something like modulus is, let's say, not necessary as k squared plus 1 greater than 0, since k is an element of the real numbers. We can say k element of the real numbers. Once again, that's enough argument to say that k squared plus 1 is going to be positive. This is always going to be positive. So therefore, if you take this whole value, the modulus of that value is the same as the value. So now we have shown that the modulus of r minus s is equal to the expression that they had here. They had, if I remember correctly, it's the square root of 2k squared plus 1 divided by k squared plus 1. So now we can move on to the final part of the question. The final part of the question is asking us to deduce that the horizontal distance between the 2 points of intersection of the graphs of this graph and this graph is the square root of 3 divided by 2. Now when they say deduce, it's likely that what you've already done so far is going to be helpful in finding this thing. So we're going to be on the lookout for equations of the form 4 times k squared plus 1 x squared plus 4kx minus 1 equals 0, because that will likely lead us to a solution that's going to involve this equation that we just derived here. That's how they work. Generally, when you have some formula that you have to derive and then they say deduce something, you're likely going to not have wasted any effort, because the formula that you just derived is going to be crucial in solving this question. So if we look at these two graphs and we write them down, we have y equals x cubed plus 9x squared plus 3x plus 1, and y equals x cubed plus x squared minus x plus 2. So I'm going to write them down, and I'm going to say when the graphs, and I'm going to write down the two graphs. If I remember correctly, they are y equals x cubed plus 9x squared plus 3x plus 1, and the graph y equals x cubed plus x squared minus x plus 2, and we're going to say when these two graphs intersect, what's going to happen? What's going to happen? So when they intersect, the two y values must be equal. So therefore this y value, which is all of this stuff, and the other y value, which is all of this stuff, must be equal to each other. So therefore we can say that x cubed plus 9x squared plus 3x plus 1 must be equal to x cubed plus x squared minus x plus 2. Now if we simplify this thing down, we can see the x cube and x cube cancel. We get 9x squared minus x squared, which is going to be 8x squared, and then we get plus 3x minus x, which is going to be plus 4x, and then this plus 1 and the minus 2 from the other side are going to give us minus 1 equal to 0. Now, at this point, you're going to have to heavily rely on pattern recognition, because if you take a look at this thing, you see we have 8x squared plus 4x minus 1. If you go up and you consider the pattern of the equation that they had above, the pattern of 4 times k squared plus 1 x squared plus 4kx minus 1 equals 0, you will notice that if k is equal to 1, what we get is 4 times 1 plus 1, which is 8x squared plus 4 times 1 times x, or plus 4x minus 1 equals 0. So the case when k is equal to 1 of this thing right here is exactly what we have down there. So that's what I said, you need a lot of pattern recognition to spot that, but once you spot that, you can realize why we've been doing all of this work. It's so that we can get our final answer. So here, for the next part of the question, what we're going to have to do is to say that this thing right here is of the form that we had above, but k is equal to 1. So for that, what I'm going to do is to write this as 4 times 1 squared plus 1 x squared plus 4 times 1 times x minus 1 equals 0. And now we're going to say, note that the above is of the form that we had above, which was 4 times k squared plus 1 x squared and then plus 4kx minus 1 equals 0, where k is equal to 1. So now we're establishing a relationship between the thing that we have right here, which is this, and our previous solution that we had so far. So now we know that there's this connection between this graph that we have when we get the intersection between this graph here and this graph here, and our previous theorem that we have been solving so far. So now we know that this graph is related to our previous formula that we had with a general k, which is now in this case a specific k equals 1. So now, if we consider the two intersection points, the values of the x-coordinate for the two intersection points of this graph and this graph are going to be the two roots of this graph here. Since when this graph is equal to 0, the x-coordinates corresponding to that are going to be the 2 points at which this graph and this graph intersect. So therefore, if we consider the intersection points, therefore, the horizontal distance between the two intersection points of the above graphs is equal to the distance between the two roots of our formula that we have up here, 8x squared plus 4x minus 1 equals 0, is equal to modulus of r minus s, where r comma s are the two roots of our equation, which was 8x squared plus 4x minus 1 equals 0. So now that we have established this connection here, we can realize that the formula that we derived above was equal to this thing right here, and this thing right here is going to give us the solution that we're looking for. We are going to have to substitute the value of k equals 1 into this equation, and doing that, we're going to get the horizontal distance between the two roots of 8x squared plus 4x minus 1, which is going to be the horizontal distance between the two intersection points of the graphs of this graph and this graph. So now we can see we are coming full circle, and we can see that therefore that horizontal distance between the two intersection points is equal to the formula that we had, which is the square root of 2k squared plus 1 divided by k squared plus 1 when k is equal to 1, which is going to be the square root of 2 times 1 squared plus 1 divided by 1 squared plus 1, since k is equal to 1. And now if we simplify this, we can see we have the square root of 2 times 1, which is 2 plus 1 divided by 1 plus 1, which is equal to the square root of 3 divide by 2. And hence, the distance, the horizontal distance between the two intersection points of the above two graphs is equal to the distance between the two roots of this equation here, which, as we found earlier from the general formula, is going to be equal to the square root of 2k squared plus 1 divided by k squared plus 1, which we have solved to be equal to the square root of 3 divided by 2 as the question said. So there we go. This is the total complete solution for this question. You can of course make things a little bit shorter. You could perhaps not put as many line spacings as I have. You could make your handwriting small and all of that, and you could take up less space, but this is going to be the full and complete solution for this part A question of 11 part A. Finally, let's consider the marks given. For the total question 11, you get 150 marks. Now usually, the part A and part B's marks are usually divided either 75-75 as in 50-50 total division, or sometimes if part A is bigger than part B, part A could get 80 or 85 marks while part B gets 65 or 70 marks. Now in this particular case, it appears that part A is bigger than part B, and due to that I have given part A 85 total marks while giving part B 65 total marks. So if we take a look at the marks that I have given here, for the start, when you check the discriminant and see that the discriminant is greater than 0 and find that the two roots are real and distinct, you will get 5 marks. When you try f of 0 and see that that cannot be 0, so f of 0 is not equal to 0, meaning that 0 is not one of the roots, so the roots are non-zero, you get another 5 marks. When you combine that and say the statement that the f of x equals 0 has two non-zero, real and distinct roots, you get 5 marks. Then, when you consider alpha and beta and write down alpha plus beta and alpha times beta, you're going to get 5 marks for alpha plus beta and 5 marks for alpha times beta. After that, when you consider r and s and write down the quadratic equation with roots r and s as being x minus r times x minus s equals 0, you're going to get 5 marks. When you then simplify that down and write it in terms of alpha plus beta and alpha times beta, you're going to get about 10 marks. Then, when you substitute them in and rearrange it until you get the form that they had in the question, which was 4 times k squared plus 1 x squared plus 4kx minus 1 equals 0, you're going to get 10 marks. Afterwards, when you simplify it down with the roots and get the two roots in the form of minus k plus or minus the square root of 2k squared plus 1 divided by 2 times k squared plus 1, you're going to get another 10 marks. When you simplify this down using the modulus and realize that this part is going to get cancelled and also that the modulus is not necessary, and write down this information that you have here, you're going to get another 10 marks. Remember, this information and the simplification and cutting out the minus k divided by 2 times k squared plus 1, all of that is important for getting this 10 marks. Afterwards, when you then use this logic to realize that these two graphs intersect when they are equal, simplify it down and get it into the form of 4 times k squared plus 1 x squared plus 4kx minus 1 equals 0. For all of that and identifying that k is equal to 1, you get another 10 marks. And finally, when you solve that down, simplify it and realize that k equals 1 means that this is going to be substituted into here, and simplify until you get the square root of 3 divided by 2, you're going to get another 5 marks. And that's going to be all of the marks for this question. So that's going to be all for this video. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.